I'm Nasser Kamal.
I'm William Wisen.
I'm Karen Gauze.
I'm Hassan Sheikh.
Chris Cooper.
And I'm Tyler Johnson.
All right. So this is the overall SnARK gene. We have the polymerase will be moving from the 5' here to the 3' over here. It's going to bind to the INR region at the +1 initiation site, which will be right here. And the transcription factors that are going to help it bind will be binding to the upstream BAE binding element, also known as the beta recognition element. We have the TATA box, which is all part of the core promoter, the downstream BAE binding element, and the distal attitude element. And all of this forms the core promoter.
All right, as said before, we have the stem part of the gene, which represents the stimulator or the enhancer. And all the black areas represent sort of insulators, where the end one represents the insulator for preventing the transcription to different genes. The stem can interact with the MED complex and create a loop that helps regulate the system and in many ways helps upregulate the system.
Well, one of the preliminary steps for transcription is to have transcription factors, particularly transcription factor class 2D is going to bind to the TATA box, and you're going to have associated proteins that bind to the initiation region and the distal attitude element. And this transcription factor D is one of the first transcription factors to actually come and initiate transcription.
Okay, so here what we have is transcription factor 2B, and it comes in and binds to the BAE binding element upstream and downstream, and it stabilizes the DNA protein complex. And then what comes in next is TF2A goes right here, and it further stabilizes the DNA protein complex.
Alright, after that, transcription factor 2F comes in and recruits more RNA polymerase. What this does, it recruits the OspPol gene for us. The OspPol gene attaches to INR to initiate transcription, and it also has the NTD and the CTD. The NTD is the N-terminal domain, and the CTD is the C-terminal domain.
Now, the MED complex binds other transcription factors such as transcription factor 2E and H. Transcription factor E helps bring in H to the PIC, and transcription factor H deals with phosphorylation and ends up creating the open complex. What happens is the ATP floods into the H and allows it to react, which thus creates the open complex.
All right, as the transcription bubble is opened up, transcription factors B, E, and H are all dissociate off, and the polymerase begins to move down the SnARK gene and replicating a complementary strand of RNA to the SnARK gene until it reaches the end of the gene itself.
So for termination, we have OspPol approaching the poly A tail. This starts to slow down transcription. This allows the KE and the BDO to bind, which come in and bind to OspPol. This allows the TF2D to detach, come off of the gene, as well as OspPol. And that is the completion of transcription.
After that, transcription factor 2F attaches to the INR and recruits more RNA polymerase.